Yes, dear students, after the break time, now it is just the time, after reviewing the very briefly, of course, the theory part, and underlining that von Mises or Tresca yield criteria is the answer. Okay, for the question. Yeah, well, although the load is not uniaxial, although the geometry of the body is not simple cylindrical in shape, well, how can use the test results to say something whether object gonna be safe and so securely used? The answer is see the yield limit. Well, not which limit, von Mises limit, von Mises stress. Use von Mises yield criteria or Tresca yield criteria. These are comparable criteria. But for ductile materials, now, well, don't use von Mises criteria. May use Morse yield criteria. Okay, since this is not a course, strength of materials course, not purely theory course, then I say only, well, be aware for ductile materials, the other criteria we have to use. Okay, if there is a software and you're in doubt whether that software solves the problem correctly, it is the famous method, or say not it's a package program, professionally marketed one, but as the person using a certain high-level language, for instance, Python, okay, or Fortran, etc. Neyse, you wrote the codes, you have the algorithm, you have the equations, and then you achieve to describe the phenomena mathematically. You have sets of equations, etc. And then to solve the equations, you wrote the codes. But you are still in doubt whether that program can be used correctly output the results, or can output the results, cannot be exact, but approximately true. Well, to answer such questions, you know the method. For verification purpose, we select a simple problem first. Okay, for that problem, analytical solution is not difficult. Okay, solve the problem analytically using integration technique or using basic definitions on the paper, and then test it. For the same problem, okay, use the tools of the software. Now, I'm going to do the same thing right now. Well, a very simple problem. Study on that very simple problem, maybe the simplest problem to deal. It is like uniaxial test specimen. Not the same, but similar. It's going to be a rectangular prism. And then for such a loading, that problem can be found in the first chapter of strength of materials course. Okay. Well, say that, okay, create the model of that object in Inventor. And then first using the classical stress analysis tools of Inventor, perform the analysis and check, verify for verification purpose whether the results are the same. So conclude that, okay, then this means that program can be used. To be able to introduce you to the tools of Nasran, okay, instead of saying that let us create another object and then do this, do that, I'm going to say that use the same model, but perform the analysis in that case using the tools of Nasran, by which it's going to be an introduction, okay, to the environment of Nasran. In Nasran environment, what are the things to do for such kind of problems? And then, well, today time may not be sufficient to focus the attention to fusion environment. Okay, well, while I am saying the things, I expect you know how Inventor is opened. Okay, in classroom computers, yes, the software is available. Bring the cursor to the search box in Windows environment and then write the name of the software, Inventor. You can find the hyperlink in the list, and then you know the rest. Open it and then be ready to create the model of the object. Which object? Well, here, okay, take my face from the record, and then yeah, yes. Well, the previous slides, later I'm going to focus the attention, say that, well, this is this, this is that. But here the object to create this model, you see, that is the selected example for verification purpose. It's a rectangular prismatic object. Its cross-section is in that size 100 by 50, and the length of this bar is 1500 millimeters. The material of the object is in accordance with the definition of coding of American Society for Testing Materials and Testing, A36. It is a kind of steel. Okay, that is the material. It's a very simple problem, maybe the simplest one. But the condition, you know, elementary stress analysis books or corresponding courses, we say that, yeah, well, the cross section, it has been selected or to select, is sufficiently away from the surface where we have the load. Okay, not in the vicinity of the load, but sufficiently away from the surface. Okay, yeah, determine the stress. Well, if the cross section we selected is away from the terminal of the body where we have the load, then yes, can use the famous expression, definition expression, atomic bonding forces divided by the cross-sectional area. Well, since this body is in equilibrium, when we cut the body, for instance, such a cross-section, yeah, this cross-section is sufficiently away from this gripping end. Okay, at the cross-section, we have what? Atomic bonding forces. If we consider this part as if thrown away, then the remaining part will be again in equilibrium. Which forces, well, balance this effect? Well, atomic bonding forces. Okay, atomic bonding forces should be equal to 80 kilonewtons. So, well, 80 kilonewtons divided by the cross-sectional area, yes, that is the result, 16 megapascal. Okay. How about the elongation? Yeah, strain expression. Well, modulus of elasticity for that material is 200 gigapascal. Okay, when we substitute the values, then we'll see the strain when the limit is reached, 80, 10 to the power minus 6 millimeter per millimeter. And axial elongation, okay, it's a tension type loading, 0.12 millimeters. Yes, these are the results of the calculation, and then we're going to use these two numbers in the end for checking whether Nasran solved the problem as the same to its results. Classical part, fusion as well. Okay, this is my plan for the first example. Okay, software is Inventor. If not yet, please quickly open Inventor. Yeah, you see saying search box. Here is the search box. Okay, write the name of the software, Inventor, and then in the list, sure, since the software has already been installed in the classroom computers, you can find this hyperlink. Click on Autodesk Inventor Professional option. At present, the version of the software is that of this year, 2024. Okay, well, dear students, this is quite important to know. If you are from mechanical engineering program and already passed or MEC 114, you know quite well. If the object is not a single component but an assembly, And especially in the structure of the assembly, there are some standard elements such as bolt, nuts, pins, etc. Uh, then, well, while the model of the object is created, Inventor at the background creates lots of files. Well, in the memory of the computer, we have not only the file created by the user, but also lots of files in the order of, even for a simple assembly consisting with few components only, in the order of few hundreds. Files are created by the software, and those files are saved in partition C, root partition of computer, with different strange names. You did the things, you completed the work, and then that work is to be considered by another person using another computer. It is a common mistake. Well, a beginner sent the solid model file only to the other person. That person may be a teacher in school, in professional life, the designer of the other company or manufacturing company, the interested person. If only solid model file is sent, then the other person cannot open the solid model. Why? Because lots of files, valuable files, in which Inventor keeps the data, which kind of bolt is used, where is the bolt, what is the coordinate for this bolt, location dimensions, properties, lots of data files are going to be left in the memory of the computer. It has been created over there. So, well, the other person cannot open. To be able to collect the data, the ones created by the software, okay, to a common address, well, there is a special facility in the design of Inventor. Inventor uses the analogy, say that package all the things and then you can go, you can send. So the name of that facility is Pack and Go. Okay, to be able to take a right to use that facility, the necessary thing to do at the beginning is that define the work as a project. Okay? How? I'm going to answer this question in 1-2 minutes. Define the work. Now, right now, this course, it's going to be a work for verification purpose. Say that define that work as a project. Okay? And then, yes, you can indent, apply, pack and go process. If the object is an assembly, pack and go process is a must to apply. In this course, well, our object won't be an assembly. But to say that, imagine it's a component of an assembly. But since in this short course, time is not sufficient to create the other components and then to assemble the components. The aim of this course is not to educate you on assembly modeling. If you're interested with assembly modeling, then enroll to MEC 114 course. Okay? It is offered for mechanical engineering students as a mass course. You know this. So there will be no assembly in this short course to deal. So in short, can say that, okay, yeah, well, pack and go process, no need to apply. But for being safe side, for instance, today, attending to this course, you're going to make an introduction to stress analysis. But at home, later, say that, okay, yeah, it is your curiosity, or it may be your case, it is another course a word to deal, or after graduation, okay, then in the end, it's going to be an assembly. So if it is going to be an assembly indent, then pack and go process is a must to apply. So define the work as a project. And the other thing to know, when we use the calculation tools of Inventor, stress analysis tool of Inventor, and then clicking on Save button, then software, without notifying the user, taking the permission of the user, at the background inherently automatically creates a valuable folder, and the results of calculations are recorded in that folder. Log files. Another mistake. Students submit the solid model file, but forgot to submit that automatically created folder. So teacher cannot see the results of calculations, or other person cannot see the calculation results. So, well, for both of the purposes, to be able to take a right to apply pack and go process, and also to be able to guarantee that that valuable folder in which software creates and keeps the results of calculation ready to submit for the interest of the other person. Yes, define the work as a project, and in doing this, well, have a special folder, and thereafter can name in general project folder and have all the things in the project folder. Okay, no. Now, to be able to prevent clash in the memory of classroom computers, I'm going to create a special folder in the memory of your computers and say that it is the project folder. Okay? Yes, I can do it using classroom management software. Okay, these are the computers. I hope network connection is available. My test method, you may know, attention please test. Have a look at the display of your computer. Could you find this notice in the screen? That is good news for me. This means local network connection is available. Okay, and then via sending a file to your computers, well, manage to create this special folder in the memory of your computer. Well, first find a file in the memory. Okay, then I'm going to send an empty file, for instance, a Word document. Okay, in the document, well, there is something, letter A. Okay, save this file in the memory of my computer. First, where? Okay. In the memory of my computer, I have a folder for this short course. Savunma teknolojileri topluluğu. Yes. ST. Yeah, I found it. Okay. I know that it is over there, and then yes. I'm going to send the file to your computer. Send file, via which create the folder to use. Okay. Okay, the folder going to be created in few seconds in partition D. Okay, well, let's say subtech. Huh? Folder name is subtech. Defense Technology Society. In Turkish, Savunma Teknolojileri Topluluğu. Subtech. Subtech course. Okay, you're going to find in few seconds such a special folder in partition D. Yes, I created the folder. Now it is going to be the project folder. Okay, project folder. Pity. But I asked, yeah, well, could you find attention, please? Everybody said yes, hocam. One more time try. Hoping that that computer will be connected to mine. It says, please wait. Okay, no problem. If that computer, has internet connection, okay, then manually create the folder. Okay, the folder name, Savtech, You know how a folder is created in partition D. Create a folder, subtech dash course. I said something like that. Create that folder. That is okay. And then, yes, you know the value of defining the work as a project. Define the work as a project. Okay, how? After opening Inventor, that is Inventor in one, but there is nothing yet. Well, the first thing to pay attention is that, well, in Inventor, when you open Inventor, especially as the right of the administrator, admin rights, then you may find an active project. Okay? If there is an active project in Inventor environment, then you cannot define a new project. Be aware. There is such a tricky detail. Yesterday, well, one more time activated in ASC 492 course, the project. So, well, in my computer, here, there is a listing arrow. And when I click the arrow, I see the names of the already defined projects. Well, one of them is the selected one, and it is the active project. If the project is active, then you cannot define a new project. Or you cannot activate another project. So, well, inactive, if exists, inactive the project. Right now, I know your case. There is no active project in your computer, but, well, in future, going to be your case. At home, you are using your personal computer and you have a project that has already been activated. Then when you attempt to create a new project, then you receive error message. Okay, to be able to inactivate an active project, the thing to do is that drop this list and then scroll the listed ones, find default option. Well, simply, if you open Inventor, as you did it in Mac 113, okay, Inventor automatically selects that option, default option. Default option, if in the list the selected option is default, this means there is no active project. Another condition to satisfy is that in the environment of Inventor, there shouldn't be any active file. Okay, if you have already opened a solid model file or drawing file, then close them first. And then, yes, your computer, your system is ready to define the work as a new project. And then, okay, do it. Bring the cursor onto File tab, clicking drop this list, and in the list you see it is written Manage. Move the cursor onto Manage option, but don't click. And then shift the cursor to here, into this pane, and in the pane it is written Projects. Okay, do it. Click on Projects option. And this click is to bring this dialog box. Okay, in the dialog box, yes, the upper pane of the dialog, you can see the names of the already defined, already created projects. Classroom computer, it is very short. You may find only default option probably. In my computer, it's a long list. Lower pane, yes, there are some other things, but here at this stage, for defining the work as a new project, this is the button to click. At the bottom edge of the dialog box, you see it is written New. Clicked on this if it is a new project. Clicked on New tab. And then the following dialog asks whether it's a teamwork or single-man work. In school, if it is school, single-person work. So radio button is correct. Single user project. And then clicked on Next step. And then in the following stage, at this stage, in this dialog, write a meaningful name for this project. Okay, the name of this project, we may collect at the end of the course, okay, who attended and who interested with the subject things, and then can thereafter certify that that person, well, gather the things, okay, as the output of this short course, and, well, certify that, giving the certification sheet. Signed, may be signed by the president of this university, president of the society, and also the poor teacher Murat Hoca. Okay. So, well, let us know. Although, well, you know, might say that subtech course, but say, let us know who is the person. Write your surname, okay? using the letters of English alphabet. Don't use special Turkish characters or Arabic characters, I don't know. Only English alphabet, lowercase letters. And then write your ID number, because there may be two students, their surnames are the same. Let us know which one, your ID number. Okay, and then, yes, after putting a dash, let's say, capital letter, Savtech, course. One more dash, course. Meaningful name for the project. And then clicked on the button on which we have triple dots in the same dialog. It is to show the address of the project folder. In the memory, partition, they already created such a special folder. I sent a dummy file. You may, by the way, delete that Word file, okay? Yeah, that is the address for this project folder. Well, you're seeing the things in the structure of my computer. Well, it may be misleading for you. It is not the same computer, that of Twitter structure, that of classroom computers. In classroom computers, select partition D, and then over there, thanks to my creation, you have Savtech folder, okay? And indicate that folder as the project folder. I'm going to do a similar thing. Savtech folder. Okay, it is over here. And then, okay, indicate that folder. I'm going to use this nested folder. Yeah, that is the project folder, and then say OK. And then clicked on finish button. That is it. The thing to do for defining the work as a project is that. Yes. No. I created as nested. I don't want to have the submitted files mixed with the others. In my computer, the folder is broader to its content. Okay, now Inventor knows that it is an active project. Main advantage of being in an active project is that hack and go process going to be applicable, and also can ensure that all the files, the log files in which Inventor keeps the results of calculations, gonna be in the same address. No need to make a search which file is in which address. The other advantage, not main, but the other advantage, if the work has been defined as a project, then when you clicked on Save button, Inventor, without asking the address for that saving, automatically select that project folder and then save the file, saves the files over there. You need to open an existing file from the project folder. When you clicked on Open a File button, Inventor automatically brings the content of the project folder without asking the address. Since it is so via which can save time, of course. That is the other advantage. Okay, clicked on Done button, and project definition is okay. And then, yes, as usual, it is not an assembly, easy cake to create it as model, rectangular prism. Okay, then it's going to be a new file indent. So clicked on New File Creation button along the Quick Access menu bar. Or when you drop the list, clicking on File tab, you can't find the same button to click. It says New File. Clicked on New File Creation button. And then, this famous dialog box. It may be in this compact appearance. At the left-hand side, we have a pane. Over there, it is written template. Clicking on the arrow, find ENUS. Clicking on the arrow, drop this English, metric, etc. If you're going to input the values in British unit system, select English option. But if you're going to input the values in millimeter, in engineering drawing, the unit of measurement is millimeter. Everybody knows that it is so. Select metric option. After clicking the option, then in the intermediate pane, you find the template options. For creating the model of a single component, that is the template option to select. It says standard, but we know that this standard is ISO. international standardization organization, making the selection on this template option. Then Inventor conclude that, yeah, yes, you're going to obey to the rules of ISO. The unit is millimeter, etc., etc. If it were an assembly, then we would make the template selection from here. Well, for drawing purpose, make the template selection there. You know this. But in this course, there will be no studying on engineering drawing. Okay, only model and stress analysis. Okay, select this option. Standard, it says standard.ipt. IPT is the registers extension for Inventor part files, you know. And then click on create button. Yes, now in Inventor environment, all the modeling facilities are active to use. Okay, creation, editing, and some others. Okay, solid model creation starts from sketching stage. Well, for a rectangular prism, well, 2D sketch is needed. Click on Start 2D Sketch button. Clicked on this. And you know, the simulated ones right now are the core regions of the planes defined by XYZ coordinate system, Cartesian coordinate system. Select one of them. Moving the cursor to the vicinity of one of them. Well, I know the background color is not the same. Okay. Ribbon is not light, it is dark. But in that course, short course, I don't want to make a review how the background color is changed, how you enable the software for having grid lines in sketch mode, etc., etc. Well, that's why we said that prerequisite is MEC 113 and also 206. Assume that you know all of the basic things, how the model is created, how the configuration is changed, etc. Okay, why not select this plane, coordinate plane for the sketch with a click. Okay, and then create a rectangle arbitrarily, and then dimensional constraint. We know from the selected problem, the width of the cross section is 100. Inventor knows that this number is in millimeter. If necessary, make zoom out using this wheel of your mouse. From here to there, the distance is 50. Okay, that is the end of the sketching stage. Finish. Click on Finish Sketch button. And then, yes, apply the process. For a right prism, you know, to create this model, the process is extrusion. When in Creation panel, find Extrusion button. Start the process, and then, yes, region has automatically detected by the software being detected. And then into this box or that box, write the length of the prism, extrusion length 1500. Say OK. That is the model of our object. Convert it to solid model. Okay. To be able to perform thereafter stress analysis, yes, we should input the material. Thereafter, software can know the physical, mechanical, thermal properties of the object, material of the object. Okay, well, to be able to input the material, you know, along the quick access menu bar, that is the button. Okay, black, white dots we have on the surface. It looks like a ball. Clicked on this, and you know, it is to have the material selection assignment dialog box. Yes, I know, already tested. In the library that is automatically selected by the software, you know, if you bring the cursor to here and make a click, you can see in the structure of Inventor there are two libraries, material libraries. The automatically selected one, Inventor library. In this library, can see the most commonly used, very commonly used materials to their names only. Cannot find A36, I know. Autodesk library is broader in content. Select Autodesk library. Yes. Make a click on this arrow. It is next to Home button. And then select Autodesk material library. And then, yes, if you know the code of the material, write the code into the search box, or, well, it is not a very long list. Scroll, and then find still ASTM, American Society Testing Materials Testing Society. A36 is in the list. With a click indicate this material, and then right click the mouse. That is the procedure in Inventor to input material. Right click the mouse and select in this short window assign to selection option, and then close the dialog box. Okay, our object ready to deal with the rest. Save this file in the memory. Which memory? Project folder. Click on Save button or select Save As for the first saving. And then yes, Inventor, without asking me on the address, and also you, selected the project folder and then ready for our saving. Bring the cursor into this strip. It is to write the file name. Write the file name. Again, gonna say the same thing. Let me see which person saved the file. Write your surname, ID number, and then dash or not dash. Okay, not a matter for me. Part 1, let's say part 1. Okay, part 1. Who knows, next week we may study on another part and say part 2. Okay. If you want, you may record at which time you created the model. Yes, good idea. Write the date of today, March 16. Today is the 16th of March. March 16. That is the name of the file. Dear students, whatever the file name is in which we have the solid model, when we perform the calculation, stress analysis, and save the file one more time, then Inventor at the background will automatically create a folder, and the name of the folder will be exactly the same, that of the solid model file. Within that folder, you can find the log files in which Inventor keeps the results of the calculations. Okay. After the saving, then just have a look at the project folder. What we have in the project folder, only the model file. Yes. Before allowing you to leave the classroom today, in a session of today, I'm going to say that open the project folder one more time and then see the difference. That's why I say that have a look at the project folder. Okay, in my computer, okay, that is the project folder. Well, in the project folder, well, the solid model file, thanks to our saving, but the other one, you see, it's a strange file. It is the project definition file. It is created by the software. Inventor creates this file and keeps it within the folder. Thanks to this keeping, Inventor can know that it is the active project. Okay. An old version folder is automatically created. That's it in the content. Okay. Continue. To be able to find the stress analysis tools in form of push buttons along the ribbon of the software, well, the tab to select is Environments tab. Click on Environments tab, and then yes, after the click, yes, there are two alternative options for such a case. Thermal heat transfer is out of question, no heat transfer. Well, problem is not transient problem. Temperature is uniform and constant. Material, sure that throughout the it is all the points gonna be in elastic region, and there is no acceleration, static state. So if yes, yeah, well, can say two alternatives. Which alternative is recommended for such a special case? No doubt the classical stress tool of Inventor, because it is easier to use, not Nasra. Okay. So, well, first attempt to use that facility, bring the cursor on the stress analysis. Well, to be able to make it distinguishable from the other, I say classical stress analysis tool of Inventor. Okay, clicked on this button. After the click, yes, well, find analysis tab newly appeared along the tab menu bar. And then except this one, the others are inactive at present. It says create study. Clicked on this button. Okay. And then in the dialog box, what is your purpose? According to select the radio button. If your purpose is to perform the static stress analysis, then yes, automatically selected radio button is correct. That is the option. But if your purpose is to determine resonance frequencies, and then say that, okay, if the frequency of the actuator, what is that, an electrical motor, what is that, the turbine of the aircraft, whatever it is, there is a dynamic load exerted by most of the cases motor, electrical motor, combustion engine, okay, aircraft motor. Well, if its balance is not so good, it has some undesirable runouts, and while the motor is rotating, well, it sets centrifugal dynamic loads onto the structure of the object. So, well, if the frequency of the rotation, period of centrifugal forces becomes equal to the special frequency of the structure, instead of saying special frequency, commonly we say natural frequency, then resonance will occur. Okay, when the structure comes to resonate, then theoretically the component tends to go to infinity, one direction, and the opposite direction infinity. With infinitely large amplitudes, okay, tend to vibrate. Of course, atomic bonding forces cannot balance such an extremely large deformations, then object broken. We never to have resonance, okay? Avoid having resonance. If you know the resonance frequencies for the structure for avoiding purpose, then accordingly you can select the speed of rotation. There are two alternative electrical motors. One of them, the RPM is 2000, the other one 3000. Which one is to select? If you know that the resonance frequency corresponds to 2000 RPM, never select that motor. Yeah, it is quite important and a little bit sophisticated topic to deal. But today, using the software can quickly, in even few seconds, can determine resonance frequencies. Well, if it is the case, then select model analysis option. Not today. If you're interested and say that, yeah, hocam, we are well, very enthusiastic to deal with some other things, then I say welcome, next session. Okay. Shape generator, in few years it exists in the structure. Using this facility can design the object as more sustainable. Okay, can decrease the material of the object, and via which can make the object more quick response. But here the correct option is static analysis. Clicked on OK. And then yes, the tools are active except the results and display options. Okay. If the material has already been assigned, that is okay. No need to click on assign button. Parametric table, assign, some other things, and then here we have boundary condition tools. Okay, clicked on assign button for being at the safety side, and then check in the dialog. You see the material of the object. Yes, I see it is written still ASTM A36. If you forgot to assign the material, then, well, okay, no need to turn back to model creation environment. Clicked on this button in case, and then, well, access to the same library and then select the material. It is also possible, but material has already been assigned, that is okay. Uh, one more thing. Well, in performing the analysis, what is the threshold value? Yield strength or tensile limit? Yield limit. Most of the cases, yield limit. Okay. If this limit exists, then yes, find a solution either to prevent the yielding, of course, either change the geometry of the object if it is allowed by the customer, of course, or again, if it is allowed by the customer, decrease the loads. Say that that object cannot be used under the action of such a load, while decrease the load. The elevator is not suitable for 10 people, but say maximum 8 people can use. Okay. So, well, the factor of safety going to be calculated relative to yield limit, not tensile limit. Okay. Um, okay, what else? Parametric table, no need to click on this. Close parametric table. What else? Stress analysis settings. Well, jump from here to there. Clicked on this button and then have a look at the things. Yes, the analysis is static analysis, not model analysis. At the beginning in the dialog box, we decided that it is not model analysis. Bonded, the automatically selected ones are okay. Ellipse size is 10%, that is okay. Placement distance, solver, meshing. Okay, mesh setting is the other issue to deal, not in this dialog box. You can see the existing mesh orders. I'm going to talk about such things in a few minutes. Okay, and then, yes, in this problem, we have such a boundary condition. At both of the ends, we have tension forces. 80 kilonewton is the magnitude, okay? Although we know that at this end and at the opposite end we have tension forces, well, it is necessary, since it is necessary to have a joint, okay, to perform the analysis, say that after saying that this end of the bar has been connected to the rest of the assembly, imagine. Well, at the other end, no need to repeat the boundary condition, because Inventor knows that if it has been connected to the rest of the system, then, well, and also it is in equilibrium, we said static analysis. If this end, the load is 80 kilonewtons, then Inventor knows that at the other end, the load is 80 kilonewtons. Some students repeat the assignment at the other end, and via which wastes the time and also effort. Okay, one end, this end in the example, imagine, has been connected to the rest of the body, where we have a rigid connection. Weld joint gives us a rigid connection, you know. There will be no freedom in any direction at such a joint. Okay, to be able to say that it's a fixed connection, clicked on in constraint panel, which kind of constraints can define. Fixed connection, pin joint, frictionless contacting surface. In our case, it is fixed connection. After clicking on this button, yes, clicked on this button and expand the dialog box. If in the X direction there is a freedom, in the X direction it can move, but not in the YZ directions, then select this box and then write the constraints in the X direction, in the Y direction. But in our example, there is no allowance in any direction, so no need to click on this. Okay, location button is on, if not toggle it on. It is what? It is to indicate the surface, which surface has been or is to be connected fixed. This end of the bar is fixed connected. Inventor, classical part of Inventor uses this symbol if the surface has been fixed connected. The same symbol on the button is repeated on the surface. It looks like deflected cantilever beam. Okay. When you see over a surface such a symbol, this means it has been fixed connected. And then say OK. Since we have such a concern, no need to define the force vector one more time, because Inventor knows that it is equal to the other one. The force system over that surface equals to the other force system. Okay, but in our problem, you know, the other boundary condition is a force. Clicked on this load option. Well, in the panel, we can define the boundary conditions, clicking on this as force, clicking on this as force per unit area. It is called pressure, you know. Or clicked on this, there is a bearing and surface pressure at the contact surface. Clicked on this and define the load as a moment, torsion, etc. Yes. Just about to mention such things. Okay. It's expected question and reasonable. Okay, well, it is written force, but your friend saying that, yeah, hocam, when we clicked on this, whether it's going to be uniformly distributed force or concentrated force. Yeah, yes. The answer, uniform, not concentrated. But I'm going to educate you. If it is not uniformly distributed, but at a point it is being applied, practically at a point, but theoretically, of course, there will be again a contact surface. But whenever the contact surface between the tool that is used by the surroundings of the system to apply the force is very little in size relative to the total size of the surface of the body, then can assume that it is a point force. Okay, it's an assumption, you know. To be able to define the force as a point force, there is a procedure. Then today, but latest, if you agree, well, to have one more session next week. At that time, I'm going to answer the question how the load is defined as a point force. Okay, clicked on this one, and then yes, that is the dialog box. You may find the dialog in this compact form. Without teaching the software that force is not oblique, not inclined, but normal to the surface, then okay, no need to expand it. Bring the cursor onto the surface and then make a click. But if this load is an oblique load, then yes, clicked on this button, expand the dialog box, and then clicking into this little box, say that you have the X component, Y component, Z component. Okay? In our case, it is uniaxial, so it has only, I see from this ellipse at the bottom corner, x-axis, while the loading is in the x direction. Okay, no need to expand this. Okay, the magnitude of the force, 80. Inventor accepts multiples of the unit. Instead of writing 30, this is easy writing. K, lowercase k, capital N, 80 kilonewtons. Okay, and then location button is on, indicate over which surface, indicate this end, move the cursor to the vicinity of the surface, and then make a click. And now, default configuration of Inventor may bring the representative arrow, okay, in the wrong direction. Now, it is compression type load, but we know that it is tension. So we'll use this flip-flop facility, clicked on this button, and reverse the direction. And then, well, open a parenthesis and related with the question of my dear student, said that, yeah, hocam, it is distributed or concentrated. In this simulation, we have only one error. And I know for the beginners or for the ones they try to learn the software without having the guidance of a tutor, it is quite misleading because there is only one error. it seems as if it were over there, there were a concentrated force. No, this is the representative vector. Sure that over the surface we have theoretically infinite number of forces, all of them equal in magnitude and uniformly distributed. Okay? Distributed force system we have. It is one of them. Okay, clicked on OK button. Yes. That is the boundary condition. How about the gravity force? If you calculate the weight of this object, then relative to 80,000 newtons, can conclude that it is negligible. If you say that it's a massive object, bulky object, then its weight is quite effective for the reaction forces and also the atomic bonding forces, then the answer is that clicked on this button and teach the software the Earth is which side. Okay? If you clicked on this, then yes, Inventor automatically considers that object is close to the surface of the Earth at sea level. You know, at that level, the gravitational acceleration 9.81 meter per second. And then if you indicate the surface, an existing surface, then it is to say Earth is over here or over there. But in this example, it is out of studying because weight is negligible relative to the order of magnitude of the load. Okay, and then, you know, the method is finite elements at the background. The time to divide the object into sub-portions, finite elements. For that purpose, yes, we have mesh panel, okay, mesh setting, mesh view, mesh generation. Clicked on this one and have a look at the mesh setting. In the default configuration of the software, mesh setting. But it says average element size. The average size of finite elements is 0.1. But be careful, it's a fraction. It is not the absolute value. Don't attempt to say 0.1 millimeter. No. It says in the parentheses, it is the fraction of bounding box length. Well, for our example, the maximum bounding length is 1,500. Okay? Relative to the maximum size of the object component, well, the average element size is 10%. Okay? 10%, 0.1. It is the fraction between the size of element and the maximum size of the body. Minimum element size. I know beginners say that, ya hocam average element size 0.1, minimum size 0.2. That is wrong. No, be careful. It is again fraction. Minimum element size is the 20% of the size of the average element size. Okay. Grading factor. Well, if you take finite element course, then deeply learn such things. But grading factor, it is a recommended factor by the software. 1.5 is a reasonable grading factor. Well, if in the geometry there is a changing, abrupt changing from here to there, then to be able to fit the finite elements to such a transition part, well, we aim to have smooth changing. Okay? Using grading factor, we can control the size of the finite elements at such a transition part. Okay, and also, well, over there may be some banded surfaces, curved surface. In fitting the surface of the finite element, we use maximum turn angle definition. These are further details and may be subjected in MEC 413, finite element course. But here I, in short, say that first trial, keep the default settings of the software. If you decrease the element size, of course, the limit, make it infinitesimally small. Then this means theoretical solution, complete solution, not approximate solution. This means taking it zero, very near to zero, then this means the number of finite elements within the body is infinitely large. infinite number of elements you have. It requires theoretically how many years running time? Okay, for some bodies, the runtime may be in the order of not minutes, not hours, even weeks or months. There is no such a time. And also, well, if you define the element as very little in size, then your PC, personal computer, such an ordinary computer, to its power, to its RAM size, to its screen card, to its CPU, most probably will not be sufficient. But such studies, well, finer mesh, complex geometry require workstations, okay, or even supercomputers. Turkish aerospace industry, that company, they use workstations and supercomputers, not ordinary PC. But in school, that is okay. Our purpose to educate the students, well, at school level, it is not, you see, the model of an aircraft. If it were the real model of an aircraft, then probably this computer won't be sufficient to its capacity. Okay, for the first running, yes, do not change these numbers. Next meeting, I may talk about finer mesh setting. Okay, well, generate the mesh, clicked on this button, and then yes, progress, then can see the boundaries of the finite elements. Since the material is to its color dark material, then you may not see the grid. Well, at this point, I'm going to change selecting View tab, visualization style. Of course, if I say wireframe, cannot see the mesh. Keep the recommended option, shaded with edge, but here can do it. Instead of using default IBL option, I may select two projectors option. Then it is going to be a little bit lighter. Okay, and then ask the software to see the grid. Yes, that is in accordance with the default setting, mesh setting of the software, the discretization. At the corner, Inventor reporting that, well, for this work, you see we use the default configuration. Along the body, we can find 720 elements. The number of finite elements, 720. Not infinite number of elements, finite size. The nodes, 1395 nodes. Okay. Everything is okay at this stage, okay, for this simple problem. And the rest, running time. Time to run. There is a button here in Sol panel. It says simulate or run. Clicked on this button. And then if everything is okay, boundary conditions correctly defined, mesh has been generated, then yes, that is the good news. You cannot see an error notice in the dialog. Otherwise, you see a notice, error, etc. Clicked on run. Yes, that is it. Problem has been solved. And then the automatically selected parameter is von Mises stress. You see at the top, Inventor says von Mises stress. We see the von Mises stress distribution. Well, there is a color scale. There is a bar over there. If the color, according to the common agreement, is red, this means over there there is a risk, or over there we have the maximum value. Inventor reporting that, yeah, as it is expected, at this end, stress is maximum. It is colored, the color of this part is red. And here, the maximum stress, 17.3 megapascal. The unit is megapascal. Okay? Shall we say that, it is red, so well, yielding will occur? No. Well, first, check what is the yield limit for that material. Do you know the yield limit for material A36? If you say, yok hocam, I don't know the limit for that material, then you may use this technique. There are two alternative techniques at this stage to say whether yielding will occur or not. If yielding occurs, then you cannot use this results because these are not going to be correct. You know, if yielding occurred, then you cannot use this model of the software. Well, the other technique is factor of safety. Okay? If you do not know or remember the yield limit for this material, then have a look at the factor of safety. Okay? Even for in some countries, in the countries where people never obey to the rules enacted by engineers, designers, arbitrarily use the products, overloaded manner, the factor of safety may be selected maximum 5. Okay? But if the country is, for instance, UK, Germany, Turkey, where people normally obey to the rules, especially the ones enacted by designers, okay, then factor of safety may be selected to 1.5, etc. Here, you see at the browser, after running the problems using the software, then find in the list results icon. There is a cross next to it. Drop the list. Von Mises, first principle stress, third principle stress, displacement, factor of safety. At present, the illustrated ones are von Mises stresses. Okay. Have a look at, bring the cursor onto factor of safety option, left click, right click. To be able to say that, yeah, show the factor of safety values, after right clicking, select activate option. And yes, Inventor indicating the factor of safety. You see maximum factor of safety 15, minimum 14. This means it is very safe. And actually, if we solve this problem in Fusion, Fusion is more powerful and more friendly. Fusion will say that, yeah, well, you're wasting material. Okay, use shape generator facility of the software and then decrease the material via which make the object more sustainable, save material, and also decrease its inertia. It is going to be more quick response. So when we see that factor of safety is too much, then obvious that if it were 1 or less than 1, we would say that, yeah, yielding will occur. But it is, you see, greater than 1. So this means, you know, our threshold value, yield limit. Yield limit will not be exited. This is one method. Have a look at the factor of safety. The other method, you know, if it is Inventor, for instance, turn back to model environment. You see, after running the software at the browser, you can find 2 tabs. Study tab, you see if study tab is on, can see such things at the browser. Results, boundary conditions, von Mises, etc. If it is model tab, yes, as you learned, as usual in Mac 113, you can see the icons corresponding to processes. To be able to see the yield limit, tensile limit, fracture limit, etc., well, I address, remind you, open a parenthesis, re-clicked on material button, material inputting button, and then for the same material, ASTM A36, double click the mouse. Okay, double click the mouse. After double clicking, well, the material is over here. I vanish in doing this. ASTM 36, double click, and then yes, say that okay. It is to bring this dialog box. In the dialog box, you see it is written physical. Clicked on this option, and then, well, thermal properties for A36. Thermal conductivity, specific heat, expansion coefficient, mechanical properties, Poisson ratio 0.3, Young modulus 200 gigapascal. Yes. How about the limit, yield limit? Clicked on strength, this arrow, and then the strength properties. Yield strength 250 megapascal. In our problem, the maximum stress is 17 megapascal. So yielding will never occur. Tensile strength is almost 400 megapascal. Yes. Yeah, Inventor allows you to see the properties of the material. Be aware. Okay, turn back to study environment, clicking on study tab. And then one more time, have a look at the von Mises stress, activate. Okay. As the visibility of the mesh, click on this, and then, well, if you carefully look at dear students, you can find two boundaries for the free end. This boundary my cursor is highlighting, and that surface. Well, the distance from this boundary is the location of the surface. Huh? At that instant, there was no load acting to the surface. If the prism were unloaded, then that free end would be over there. Under the action of the load, then the free end is over here. The distance from here to there is the displacement. But here, be aware, this displacement, to be able to make it visible to naked eye, is under zooming in. It is not the actual deformation. Okay. Well, in Inventor, we have such a zooming facility. Bring the cursor to display panel and then drop this list. Well, for instance, at present, it is under this zoom factor. If I increase the zoom factor, selecting this option, for instance, then the deformation will be too much, clearly distinguishable for naked eye, even for naked eye. These are not actual orders, be aware, zoom in orders. Why we have such a zoom in facility? The main reason is that, yeah, well, for uniaxial loading, everybody can say that elongation, stretching going to be in this direction, in the sense of the force, uniaxial force. But how about this case? Object is not like such a thing simple in geometry, but like a potato, very strange in shape, and the force is not uniaxial. There are lots of forces. Okay, some of them oblique, some of them inclined, some of them distributed, some of them concentrated. We have torques, bending moments, etc. Okay, then, say something. Under the action of such a loading, the potato will deform in which direction? It is quite difficult to answer. If we had only the actual order, to see the deformations in actual order, again, it is going to be unknown for us. Cannot see. Use a microscope. It is this facility actually like a microscope. Using a microscope, you can see deformation is in which direction. That's why we have such a facility. But if it is misleading for the user and you want to see the actual deformation, okay, drop this list and then select actual option. Yeah, actual deformation cannot be distinguishable for such a loading with naked eye. Because from the manual solution, you know, the maximum displacement is 0.1 millimeter. 0.12, you know, this result. Yes, axial elongation 0.12 millimeters. With naked eye, cannot sense such a displacement. Okay, in the environment, dear students, well, okay, we have a scale and can see the stress distribution, von Mises stress. But you may want to see the numerical value at a certain point. Well, software enables us to use a digital instrument, like as if real. Clicked on this button, it says probe. Okay, and then, as if you have a digital instrument, it can measure the things. Bring the cursor to this cross section and then click the mouse. Software says that von Mises is 16 megapascal. Whether it is the same number, we studied on this problem for verification purpose. Here is the solution. You see the same, 16 megapascal. Axial elongation, 0.12. Okay, check whether it is the same. Well, select displacement option. First, press escape button, toggle off probe tab, and then bring the cursor on the displacement option. It is to check whether displacement is 0.212. Right click the mouse and select activate. And then yes, we see the displacement values. The maximum displacement is at the free end, color is red. And you see displacement is 0.119, 0.12, the same. So well, Inventor, this tool of Inventor solved the problem correctly. And also for making the analysis interesting for the layperson audience, be aware you can have a video film, clicking on animate button, okay? But first exaggerate the deformation using a zoom factor, okay? And then animate. Clicked on this, it is like a video film. Clicked on the play button and then see. Well, the audience may see such a simulation, say that yeah, it is being deformed in this direction, etc. May affect the people, especially layperson. And then clicking on this button, you can record the things and have in the memory a video film in video format. Be aware. If the software is a licensed one and the usage is legal usage, then yes, to be able to see not the scales, color bar, etc. only, but also numerical values, clicked on report button, okay, and then send the data to the host computer of the company. Thanks to internet connection, now I am sending the data to the United States. And over there, a full report will be prepared. And then here is the report. Autodesk says that the user is Murat Sönmez. The time sent by that person to the host computer is 16 March 111. Okay, and physical properties for the object, mechanical properties, boundary conditions, and the results of the calculations numerically. Okay, in school, yes, you may use such a report in preparing the technical report to submit in that course. Be aware, yes, full report. Okay, dear students, how about Nasran? For the same problem, quickly study. Break time is the common demand break, but my plan, quickly repeat the problem in Nasran. It may take 15 minutes maximum, and then say that bye-bye. First session is okay. Ended the first session. Is it okay? It sounds good, better. Otherwise, if I allow you to have a break, then well, the next time after the break going to be 1 hour. 1 hour versus 15 minutes. No break, hocam. Okay. Yes, we run the problem using the classical tool of Inventor, and then, well, yes, finish the analysis. Clicked on Finish button. And then, yes, do not lose the studying calculation results. Save the file. Before such a saving stage, already at the beginning of the analysis, had a look at the project folder. We found over there project definition file and the solid model file. That is it. And now, clicked on Save button. Yes, save the file. And then refocus the attention to the project folder. That is the project folder. And in the project folder, well, there is a HTML file. If you clicked on this file, you can see the report. Okay? Here is the report. Be aware, that is the HTML file. You can find the report whenever you need one more time to have a look at. The other one, yes, project definition file. This is the solid model file, but that is new. If you use the calculation tool of Inventor and thereafter save the file, then that folder is created by the software. it uses the name of the solid model file. You see, blah blah, part 1, March 16. Open this folder, double click. You find AIP folder as nested. Open this folder. These are created by the software at the background. Open AIP folder and then find the nested one. It uses the common abbreviation FEA, Finite Element Analysis. Open this folder and yes, these are the valuable log files. Those created by the software, and thanks to the existence of such a set, then the other person can open the file and have a look at the results of the calculations. If you forgot to attach this folder in submitting the file in school, for the interest of your teacher, in professional life for the other team members, then those persons can open the solid model file but cannot see the results of the calculation. Well, to be able to be at the safety side, that's why I say, well, have all the things, the ones created by the software and also the ones created by yourself within the same address. Which address? Project folder. Okay, project folder. Okay, now refocus the attention to Inventor. After making such an underlining on the value of that automatically created folder, and then say that, okay, problem is the same problem. Study on the problem one more time, but using the tools of Nasran, which make a very short introduction to Nasran. Okay, clicked on environment step, and then make the selection on Nasran option. Okay, clicked on this. Similar appearance in the screen. Along the ribbon, we have boundary condition tools, mesh setting tools, etc. Okay, clicked on, and at the browser you see automatically we found such ones, listed ones, loads, constraint, but at present these are empty. There is nothing within them. Okay. There is an import facility. Using the basic tool of Inventor, you perform static analysis, but the rest of the studying is about related with heat transfer, thermal stress analysis. You know, instead of repeating the first analysis, starting from the beginning, you can click on this and import the data from that studying to Nasran environment. It is possible. Here there is a new button to click, but not at this stage. You perform the analysis using a certain boundary condition set, and then yes, another problem, although object is the same object, but the boundary conditions are not the same. Okay, then define the studying as a new studying. Clicked on new, and then have one more analysis at the browser to its icons and to its results. Next week, it may be the case. Next week, I'm going to say, okay, then determine, for instance, module analysis and resonance frequencies, or say that, it has some bending effects under the effect of torsions, etc. It's going to be a new analysis. So, here no need to click on this. It is going to be the only analysis, not a new analysis. Click on edit button. This edit button is recommended to click, mainly to fix the unit system. Clicked on select units button, and then yes, Nasran, knowing that in engineering, the default unit in metric countries is SI unit, but although in SI it is meter, meter is the length unit, but in engineering, we use millimeter. In engineering drawing, CAD modeling, we use millimeter. So automatically selected unit system option is CAD model unit system. In CAD model unit system, length is measured or expressed in millimeter, mass in ton, time second, Newton, force Newton, temperature Kelvin, angle degree. But if you want to see the results in megapascal, force not ton but Newton, etc., then drop this list and select SI unit system, SI. Then length will be in meter, mass kilogram, etc. Okay. Close this dialog box. The other one, yes, clicked on analysis setting. Well, I clicked on edit button and drop this list and then see the capacity or capability of NASRAN from the listed ones. NASRAN can be used for linear static analysis. Okay, linear backlink analysis, nonlinear analysis, plastic deformation, backlink, nonlinear backlink, impact analysis, model analysis, nonlinear transient response, frequency response, determining the frequency responses, multi-axial fatigue failure, vibration fatigue, and what else? Linear steady-state heat transfer, nonlinear steady-state heat transfer, nonlinear transient heat transfer. Yeah, yes. Almost, in short, all engineering problems may be in the case to deal. Very powerful software. Okay. And then in the order, although you input the material in model creation stage, then I strongly recommend click on materials button. It is because in the dialog box, not only to see the material, it has already been assigned, but also, well, to teach the software that the problem is the one, there is a heat transfer or heat generation, absorption, etc. Into this box, make a click to enable the software to use the thermal properties, specific heat, thermal conductivity, linear expansion coefficient. And you concluded that while the yielding will occur, you use the basic easy facility of Inventor and you saw that yield limit exceeded. Then yes, well, clicked on materials tab and then clicked on nonlinear tab. Okay, not today, later. Maybe interested. If you're interested, then maybe another example, nonlinear stress analysis. So this is an important, valuable dialogue. If the material has not been assigned, then click on select material button, and then yes, the libraries are the same libraries. Okay, drop the list and select the material. But since already assigned the material, gonna skip that stage. Okay, clicked on OK button. And the next order, in the order next button, on which it is written idealization. If you forgot to pass through that stage, then either you receive an error message or you cannot see the grid, although you generated the mesh. It is important. You see, these are further details, and you see, even at this level, we have more tricks in using NASRAN. NASRAN is more powerful, can solve lots of problems, so associatively, there are more tricks, more details, deeper details. That's why I address the basic stress analysis tool of Inventor. It is easier to use, but you know the conditions. Okay, clicked on idealization button. It is not optional. And then in the dialog box, teach to software. First have a look at. This is the indication. If within the material strip monitor, if the material of the object is written, that is okay. No need to click on this one for that purpose. Yeah, yes, I am sure it is written still ASTM A36. That is good. But here, drop this dialog box, have this dialog box in the screen to teach the software whether the object is a solid element or a shell. Okay? Because accordingly, NASRAN use different set of equations. Shell means thin-walled object. For instance, object is a pressurized vessel to store oxygen, nitrogen, or it is the shell of a boiler, steam generator. Pressure is in the order of how many megapascal. It is a shell. So define that object is a shell. Here it is not a shell, it is a solid element. And then say OK. Well, there is a color band here. It is, well, to say that when we generate the mesh, then the boundaries of the finite elements going to be in this color. If you don't want to see the grid in this color, then click on this and then change the color. Yeah, be aware there is such a facility. Click on OK. And then, yes, generate mesh. Mesh setting. Well, in basic part of Inventor, mesh size is expressed in the dialog, setting dialog, as a fraction, 0, 1, 0, 2. But in Nasra, mesh size, default mesh size is 0.564 unit is meter, since we selected SI. That is in the default setting, not fracture, but the size of the element, average size of finite element, say 56 millimeters. Well, there's an adjuster here, sweep, to be able to increase the number of elements, to be able to have the solution more accurate, more precise. Sweep it to finer mesh size. But be aware, if you do this, runtime may be very great, and your computer may not be capable to solve that problem. Okay, be aware. And here in this dialog, you can change the type of element from parabolic to linear boundaries. And then either in this dialog, clicked on generate mesh, or there clicked on this in the ribbon, along the ribbon, generate mesh. Yes, now that is okay. This is the mesh grid, mesh size and the mesh in the default setting of Nasra. Okay, and then boundary conditions. Constraint, clicked on this. How many constraints are defined? Fixed connection, pin connection, frictionless surface connection, surface contact. In our case, it is fixed connection. That is the dialog box. In the dialog box, yes, well, it is possible to allow freedom, okay, to have in X direction, Y direction, Z direction. Removing the selection marks, then can say that in this direction there is a freedom, in the other no. But default settings, you see, it cannot translate, it cannot rotate, because it is welded joint. It's a welded joint. Okay, and then which surface is to fix? Well, this surface indicated. Okay, it is a fixed connection. Clicked on this button, and then default color for the symbol that is used. In classical part, it looks like cantilever, banded cantilever beam. But in Nasran, it is going to be double arrow. In which color? Cyan. Cyan is the default setting, is the color. You can change the color if you want. But in basic part of Inventor, have only one yellowish arrow when we indicate the surface that over there is a force, and it is going to be maybe misleading for the others, for the user. It looks like, because only one vector, it is as if concentrated force. But in Nasran, yes, where we can, using a facility, we can prevent such a misconsideration. But how? Moving the sweep, density sweep, from 0 position to the other side. But for having the symbol to say that it has been fixedly connected, one symbol is enough. Don't use this facility. Okay, and then say okay. Yes, these are the symbols. Double arrows, in this, in this, in that. This means all the direction has been fixedly connected. At the other hand, we have force distribution. Clicked on load step, and then in the dialog box, similar list, automatically selected option is force. It might be moment, it might be distributed load, but say, hocam, you're saying distributed load, but it is distributed load. Distributed load option implies that the unit of the quantity is newtons per meter squared or newtons per meter. If the contact area is a strip, newtons per meter. Hydrostatic load, pressure, gravity, remote force, thermal boundary conditions, temperature, convection coefficient, radiation coefficient, heat generation, heat flux. Yes, for such boundary conditions, Nastran can be used, ready. But in our case, it is force type boundary condition, selected force. Okay. Well, if you select from this list component option, then this means you know the components of the force. You know, if it is an oblique or inclined force, for our convenience, we use X, Y, Z components. But in our case, don't waste time. If it is components, then into these boxes write X, Y, Z components. Well, in classical usage, we have flip-flop facility. If the force is compression, but although it is tension type, then, you know, click on flip-flop button. In Nastran, there is no flip-flop button to change the direction sense of the force. The method is that. Well, see the ellipse at the corner, X, Y, Z axis. X-axis to its positive sense in this direction. Okay, then if the component of the force is in the same sense, then into this box write the component, magnitude of the component as positive. To make it opposite direction, write it as negative. Okay, be aware. But in our case, no need to deal with X, Y, Z components. Two of them 0, one of them 80,000. Select normal to surface option. Okay, and into this box write the value. It is positive. I know that positive x-axis is in this way, in the sense of the forces. 80. Since the unit it is in the parentheses newtons, write 80,000. Okay. And then, to be able to prevent misconsiderations via having more than one arrows, use this facility, density facility. Hold it and move it a little bit away from the limit to the right, not too much. Only if you have only few arrows, then other person can say that it is not a single but a distributed load. This is sufficient. And then indicate the surface and then click on OK button. Yes, you see we have not only one arrow but more arrows. Okay, we prepare the things for the running time. I think all the things are okay. And then time to solve the problem. Click on Run button. And then, yes, at the browser, you're going to see lots of text. They will scroll. And that is the good news. Otherwise, we will find an error message. If there were something that is wrong, related with boundaries, or you forgot to pass through idealization stage, then you're going to have the bad news. Okay, click on OK button. And then the results coming. Yes, the automatically selected one, you see now at the results part, these are active, visible. Von Mises yield limit, von Mises stresses are being represented in Pascal, not Pascal, megapascal. Okay, and then see, maximum stress is at this end 18 megapascal. Okay, and then similarly you can take a probe, clicking on this button, and then indicate, you see, von Mises stress at such a cross section 16 megapascal. But in the vicinity of this fixed connection, it is 18 megapascal. Similarly, you can animate the things clicking on this button. And similarly, be aware that this deformation is under exaggeration, under zooming in. Okay, well, here the video. Sorry? Yönü doğruysa bazen oku içeride koyabiliyor. Önemli değil. Ok içeride çıktı sende. Dert etme onu. Belki zıt yönde yarattın, o yüzden oldu. Orada pozitif yazdıysan o tension force'tur. Önemli olan o. Yes, you can see the simulation like this. It is possible. If you want to see the actual deformation, by the way, if you turn back to boundary condition environment, then need to have a look at one more time the results of the calculations. Bring the cursor to the browser, one misses for instance, or displacement, or set factor of safety, which one is the case. Right click the mouse. In using Nasran, you cannot find active option, but you find display option. It is to select for the same purpose. Okay. Then software allows us to see the results one more time. Okay, to be able to see the actual order, then click on this button. It is next to video icon. Okay. It is to bring this dialog box. Select deform options and then actual radio button. If you select this radio button, then you see the deformations without any zoom factor. Okay, be aware. And then there are some other things, of course, lots of things actually in detail, especially for complex problems. But say this is a short course, and I have already taken your agreement. Hocam, 15 minutes sounds good, not 1 hour. Okay, say that we completed the studying, and then yes, time to exit. Clicked on exit button, finish Nasran, and then save the file one more time. But I know this is the question. Hocam, for the same object, we use the classical tool. We had data in the memory, but say, well, repeated the solution using Nasran. When we save, then the data will coincide. There will be interference. No. Inventor Nasran, if you use Inventor Nasran will create a different folder to keep the data in the memory. Yes, see that it is true. Clicked on Save button. Okay, and then have a look at the project folder. Within the project folder, you see the main folder. The main folder is the same. Yes, it is the automatically created folder. Open it. Now here, not only IAP folder, we have one more, INCAT. Yeah, INCAT folder is the folder to keep the results of Nasran solution. Next week, if you agree and attend to the second session, then say that, okay, upload the results of the calculation. How? Showing the address within this nested folder. Opening cat folder, finite element folder, and then these are the valuable files, log files. Okay. Dear students, for the first session of the course, that's all. But for being safety side, I say zip the project folder. Okay, and then after your zipping, I'm going to collect your project folders to my computer. And also I recommend to continue on the rest or to study it, to make a review on the same things. I recommend send that compressed folder to your email address or your Google account, Google Drive, Dropbox. I recommend send it to a cloud. Yes. But I said that, yeah, folder. Yeah, yes. Yeah, yes, it is quite important. Yes. I forgot to say, in naming the folder, I said subtech blah. But say, when I collect the folders, then all of them, since will be in the same, are in the same name, will be clash in the memory of my computer. So well, after closing the file, all the files, okay, even you may close Inventor, no need to keep. And then, dear students, bring the cursor to the memory. Over there, you know the course folder. It says Savtech Bula. Right-click the mouse and rename it. Renaming the folder, don't forget to add your surname first. Surname, ID number, and then the rest. Savtech course. I have created that folder automatically in the memory of your computer. Please rename the folder, adding your surname and name. Say ID number, sorry. Well, I cannot rename it because the file is open. Close the file, then I can rename the folder. Okay. After closing the file, then you can rename the folder. Now, Inventor is open, probably seeing some files at the background. So let me close Inventor and then try again. Yes, okay. And then how you can zip the folder? Bring the cursor onto the course folder, name of the course folder. Right-click the mouse, and then in the list find 7Z option. The available archiving software in the classroom computers is 7-zip. Well, move the cursor to this window, sub-dialog. It says Add to Archive. In the jargon, we say zip. Okay. Add to Archive. With a click, select Add to Archive. And then in this dialog box, do not change any setting. 7Z format is the recommended format. And then simply click on OK button. That is it. And then, do not shut down your computers. Do not log off the session. Well, but you may leave the classroom. Okay, remotely I'm going to collect your files to my computer. And also repeat the recommendation. Send the zip folder to your email address. Okay. Thank you so much, dear students, for your interest. Well, the first session is completed. Have a nice day, nice weekend holiday. If you agree and demand the second session, well, the President of Society will ask you whether second session is a common demand. If yes, then you can find me at this stage next week, probably on Saturday. Okay, then, see you then. Bye-bye. Thank you. Thank you so much. Thank you. Thank you for your interest and enthusiasm. And also one more time, deliver my thanks to the societies, okay, for this opportunity.